Okay.
Yeah, so we are looking at binomial. Yeah, binomial. So today is the first. Okay, so we're looking at binomial. So now, by to begin with, by means two. There was that question at secondary they used to ask us. A bicycle always has a meaning to refer to two cycles, bicycles, two cycles. So by, it means we're dealing with two things here. So in a nutshell, just to quicken the whole process, so we're going to look at something like maybe we have a plus b to the power n. Okay, this is one of the example that I can give for binomial. So we have this, and then we need to know how to have this expanded, how to do the expansion of such a given expression. So for instance, if this n is equal to, let's say if this n is a 1, okay, we just have the same a plus b. If this we have a plus b to the power 2, if this becomes a 2, then it means we have a plus b times a plus b, like that, okay, which we can work out to have a times, so we can have a, this a here multiplied by everything there, so have a plus b, then the plus b that remains we can have plus b multiplying by a plus b, like that. So this gives us a times a, we get a squared, plus a times b, we get ab, plus this a times b, we get another ab, plus this b times that b, we get b squared. So we get a squared plus ab plus ab, we get 2ab. Okay, it's like an orange plus an orange, we get 2 oranges. Then plus b squared. So this is what we get in that expansion. So now, in binomial, it's easier for us to work out the a plus b to the power 2. So what if we have a plus b to the power 3? Meaning this one calls for us to have a plus b times a plus b times a plus b. Okay, now you can imagine this one quite right, we can work it out like we have done that. Now imagine you have a plus b to the power, let's say 15, or even this is too much, just the power 7. Okay, so this gives us a bit of some challenges to work with. So with binomial, we're going to learn some tactics and techniques that we can use to just shorten this whole process. So that's what we are going to do here. Okay, so we need to move very fast, Trace. Like I said, you shouldn't wait, tell me to wait for you to capture. So the moment I'm done, then I have to rub and then we move on. Hope that is okay.
Right.
Great. So now, yeah. So let's look at what we call as Pascal's triangle quickly. Yeah, we look at Pascal's triangle. So under Pascal's triangle, we have, if we have, yes.
Your microphone is moving.
What has it done? What has it done?
Yakati.
That should be network. Yeah, that should be network, Trace. But you're able to get me now?
Yeah.
You're able to see also what I'm doing?
Yes.
Yeah, so we want to build the Pascal's triangle. You see that a plus b to the power 0, it will give us 1. Okay? Yes. Any number except for 0, when you raise it to the power 0, you get a 1. So that will give us a 1. And then this part we have, when we have this to the power 1 there, these are the coefficients. So we are building the Pascal's triangle, which is a triangle that has coefficients of these expansions this side. So this one has 1 as a coefficient. This one has got 1 and 1 there as the coefficients. You understand what I mean by this? So this one we have a plus b to the power 2. So when you're building this Pascal's triangle, you first begin by writing a 1 outside here. Later on, you add these two that are on top, the immediate numbers that are on top here. You add them to get the number in between there. Is that okay? Then at the end there, again, you put a 1. So for to the power 3, we have there's a 1 here, so we always start with a 1. So we have this one, then we add this one plus this 2 to get a 3 here. Do you have the video? Do you still have the video? Okay, so 2 plus 1, we get a 3 here. Then we finally have another 3 there.
We have 1.
So a plus b to the power 4, we're going to have a 1 here. Then we add this plus this to get a 4. Then we add again this plus this to get a 6. This plus this to get a 4. Then we have a 1 at the end there. So that's how we do the binomial. That's how we grow, or we develop rather, the Pascal's triangle. So that's how we build the Pascal's triangle. Yeah, so from there now, after we have done that, what we need to do is we have a plus b, a plus b, a plus b, a plus b. So we need to put this now here to make it like these are just the coefficients. When you expand, these will be the coefficients. The first term will have the coefficient 1. The second term here will have a 4. The third term here will have a 6. The fourth term, the fourth term will have a 4. And the fifth term will have a 1 as a coefficient. Is that okay? Yeah. So now let's try to feed this. Of course, this one will give us as a 1 when we try to work out this one. Then this one, a plus b, it will simply be a plus b. Okay? It will just be like that. That's what we are going to have. So for this one, this is for this one. So for this one, when we expand this one, what we are going to have is here we are going to have a. Okay, now one thing you need to understand is this, that when you are putting the numbers in the Pascal's triangle, let me redo this one. So you get the first number a and put it here, then it should have the highest power, which is 1. Then this other one should be there also with a 0. It should start from 0. The a starts with the highest power and it will reduce until it becomes a to the power 0. While the b starts with 0 and it will be increasing until it gets the highest power. That's what you do there. So a starts with the highest power, which is 1. B starts with a 0. Then the moment you go to the next step, the a, which was a 1, it will reduce by 1. It will become a to the power 0. The b, which was a 0, it now becomes b to the power 1. So that's what happens. So we go to this one, we have a, it will be to the power 2, since we have the biggest power to be 2. Then b will have a 0. Then we are saying plus, okay, plus. Then we go to the next term, the a will reduce by 1, so it will be a to the power 1. The b will gain a 1 from 0, it will go to 1, so it will be b to the power 1. And then we have plus, and then the a which had power 1, when we subtract 1, it will become a to the power 0. Okay, it will become a to the power 0. It would have lost that one. And then the b, which had the 1, it will gain the 1 and become b to the power 2. And we are done with that one. So the same applies when we come to this one. The a begins with the 3 because that's the highest power, while the b begins with a 0. Okay, plus, then The next step, the A will reduce by 1 to become 2. The B will gain a 1 to become B to the power 1. Okay? And then when we go to the third term, the A will reduce by 1 into B to the power 1, while the B will gain the 1 to become B to the power 2. Okay? And then we have our plus there. And then finally, the A will reduce from 1 to 0, A to the power 0. And the B will gain the 1 from 2 to B to the power 3. Then the last one here, we have A to the power 4, B to the power 0. Okay, can we leave out the 0?
Oh yeah, yes, it's okay.
Yeah, B to the power 0 to give us a 1, so we can remove it. And we also know the coefficient 1 times A to the power 4 to be A to the power 4, so we can remove this one as well. Then we have plus, then the A here would be A to the power 3.
3.
Then B to the power 1, we can just write a B. Because here it was B to the power 0, like it starts from 0, then it gains a 1. So you can just write B. Just a B. Then from there, the A will be squared, while the B will be also squared. It would have gained the 1. While the A loses, the B gains. So we have plus there also. And then here we have A reduces by 1, it becomes to the power 1. So there's no need of writing the 1. We can just write A just like that. And then B, from 2, it gains a 1, it becomes B to the power 3. Then we say plus. Then this one as a coefficient, we can simply remove it. So then we have B to the power 4. Because the A is going to be to the power 0,
Yes.
and A to the power 0 simply gives us a 1, isn't it? Yeah, so that's how we build the Pascal's triangle. Any question on the Pascal's triangle? Any question on the Pascal's triangle? Any question on the... Okay, great. That's good if it's clear. So
Yes.
great. So let me just do one example question that we can look at concerning the Pascal's triangle. So let's look at one example.
Do they bring this in the exams?
No, they don't ask you. They don't ask you to use Pascal's triangle. They will ask you simply to expand or to find a certain term. Then what you use is up to you. So if you want, you can use this. So for example, you can say in the expansion of, let's say we have x plus y to the power 4. Yeah, or not in the expansion, give the expansion, give the expansion of x plus y to the power 4 using Pascal's.
Oh, I've seen
Come again.
this question.
Come again.
And same, I've seen this question before.
So meaning it can come. So now Pascal's triangle, we can build it quickly here. Let's build the Pascal's triangle. So it's usually 1, 1, 1, then 1, 1 plus 1, 2, then 1 there. So this is for 0, this is for 1, as in the powers. Then here, 1 plus 1, 3, 1,
then 3 in the
then 1,
1,
4, 6, 4, 1.
Yes.
So these are the coefficients for the expansion to the power 4. So this is what we are looking at. So these are the coefficients. So we have this and we have to give the expansion to the power 4. So we can simply write those and say 1, we have 1, we have 4, we have 6, we have 4, and a 1 there. So now we start filling these. So we're going to have x to the power 4, then y is to the power 0 at this point. So there's no need of writing it. So plus, then we have 4, x to the power 3, it reduces by 1. Then y from 0 goes to 1.
Yes.
Plus, then here x becomes squared and y also becomes squared. Like that. Then here we have x reduces by 1, it becomes to the power 1, while the y becomes to the power 3. Plus x from 1, it will be x to the power 0. We can't write it because we know it's 1. But y from power 3 goes to y to the power 4. Like that. So this one has nothing to do there, and this one has nothing to do there. So this is the expansion to the power 4. So this is the expansion we have for this. Yeah, so this is how you do the expansion using Pascal's triangle. Any question on that?
How come you never used to explain like this in class?
Really? No, I'm sure sometimes the understanding also gets better when you are growing. So 2 years down the line or 1 year down the line, you have grown older, and so the brain also. Come again?
We know the pain of failing.
Yeah, exactly. So that also contributes to how fast you understand these things. So we are done with the Pascal's triangle. Now, after we're done with the Pascal's triangle, yesterday we looked at something like the combination. We said n, we combine with r. We looked at this combination, which can also be written as n choose r. We looked at this one yesterday, which we said is n factorial over r factorial. Then we subtract n minus r factorial. This is how we get the coefficients in binomial expansion. When you're dealing with binomial expansion, this is how we get what's this? The coefficients. So from this, that's how we get the coefficient. Now, you understand that sometimes you're going to have, like, let's say a plus b to the power a very big number here, maybe 30. So that will be very difficult for you to build a Pascal's triangle here, because you need something very big for you to come up with this. So there should be a way of doing it to come up with the expansion even without doing the Pascal's triangle. There should be something like that.
Exactly.
Yeah, so now this brings us to the idea of the binomial theorem. So this brings us to the idea of the binomial theorem. So binomial theorem. Okay, so this brings us to the idea of the binomial theorem. So the binomial theorem, we have a theorem. I'll not state it, I'll just give the way it goes and how we can use it. So now we have n, we are using combination, the one we learned yesterday. So with a 0 there. Maybe before we can do this one, there is something also we need to understand, that when we have n, before we conclude this, let's say we have 5 combined with 5. So this, which gives us 5 choose 5, like this. So this one, when we do the breakdown here, we're going to have 5 factorial over 5 factorial. Then here,
open bracket 5.
we're going to have 5 minus 5 factorial, right?
Yes.
Yeah, so you need to take note that 0 factorial is 1. Okay? 0 factorial is 1. So this one you need to understand it. 0 factorial is 1. That one you need to understand it. Yes. So then in this expansion we are going to have 5 factorial over 5 factorial. 5 minus 5 is 0 factorial, which gives us a 1. So that simply gives us a 1.
1.
Yes. So any number, choose the same number, we get a 1. So this you need to understand. Then the other thing also we need to understand is when we have 5 choose 0. Let's say this one. This one is going to be 5 factorial over 0 factorial.
Open
Then we have
bracket
5 minus 0.
minus 0 factorial.
So 5 factorial over 0 factorial is 1. 5 minus 0 is 5 factorial. So this gives us a 1 as well. Yeah. So you need to take note here of certain things. So we are saying take note of things. 1, 0 factorial is equal to 1. The other thing you need to take note of is n choose n. This gives us 1. And the third one is that n choose 0 is also equal to 1. So any number, choose the combine it with itself, it will give you 1. Any number you combine it with 0, it will give you 1. Yeah, so that's what we have there. So this combination is just that we didn't talk about it, and I'll explain it later, even when we meet in school. So this you need to take note as we are going to do the binomial expansion. We'll need this information here. Okay, so in the binomial theorem we have, it starts with n choose 0. Then for a plus b, let's say for instance is in the expansion of a plus b, in the expansion of a plus b to the power n, this is going to be n choose 0. Then the a begins with the highest power like we are saying, while the b begins with a 0. Okay, the b begins with a 0. So from there we have plus n choose 1, meaning a. Now at every point a will be reducing by 1. So here you have n minus 1, okay, while the b will gain a 1 like that. Yes. So a carries this minus this as a power. So n minus 0 you get n, while b carries just this down here as a power. So at this point we have a. Come again?
Let's put a figure there on n.
Oh, this is a general formula.
Oh, okay.
Yes, this is a general theorem. This is a general theorem. So we'll do one with figures, but this is a general theorem. So n, we begin with n choose 0. These are options that you can choose, either Pascal's triangle or this or anything. They are all there to help you expand the binomial expressions. So we begin with n to 0. A gets the power of this minus this. That's the power you have there. While B just gets this power down here. We got the next one. From 0, this comes 1. So A will get this minus this. B will just get this. Then we go to the next one. We're going to have n choose 2. So A will have this minus this, which is n minus 2. B will have a 2 plus. Then we can put some dots to show that there's a lot of numbers there because we are dealing with n and we don't know what that n is. So we just put dots, then plus. Now, in the midst of this entire expansion, all the way as you expand, there is a part here which we have as n choose r minus 1, n choose r minus 1, then we are going to have x to the power, let me say we have, let's use the same a, so we have a to the power, since a takes this minus this, so I have n minus r minus 1, then b will carry just r minus 1 as the power. In the midst of the expansion, there is something like this, then plus, then we have these dots, plus, then finally the final term would be n choose n with the a to the power, n minus n, you get a 0, b will carry the power down here, which is n. So that's what we are going to have there. Now, you need to pay particular attention to this part here. Okay, so this part is what we use to say, we can give you an expansion like this one and simply ask you to say, find the fifth term in the expansion of this binomial expression. Then when you're finding the fifth term, there will be no need of you expanding all the way. There will be no need. You just need to pick this formula here. You pick this formula, it will give you the exact term you are looking for in any given expansion, yet without you solving that expansion. You get that? Are we together on that one?
Yes, I can hear that.
Great. So let's use this formula to do the expansion. One of the expansion. Let's use this formula. We see what it's going to give us. So I'll rub it because I have it in my head. I hope you have it somewhere so that we don't.
Yes, sir.
Yeah. So we tried to do a plus b to the power 4, and if I remember very well, it gave us a to the power 4 plus, was it 4 here?
Yeah, it was
A to the
4.
power 3,
A,
b
3.
plus, then 6 here,
It was 6.
6a squared b squared plus 4 a b to the power 3 plus b to the
Plus
power
1.
4. Something like this, if I remember very well.
That's how it was.
Yes. Now let's use the binomial theorem. So we have a plus b to the power 4. This is going to be, the n here is the 4. So we have 4 choose 0. Then we have a. Then the power of a is 4 minus 0, which is just 4. While the power of b is this power down here, which is 0, plus 4 choose 2. Then a will take 4 minus 2. No, we have moved from 0 to 2. We need to have a 1 here first. So we have a 1. So the power of a now will be 4 minus 1, which is 3. While the power of b will be this one here, plus the next one will be 4 choose 2. Then a will carry a, 4 minus 2, we get 2. Then b will carry the power that is down here, which is 2, plus. Then we have 4 choose 3. Then a will be 4 minus 3, which is what? 1. Then b will carry the 3 here. Then plus. Finally, we have 4 choose 4, which is now going to be a will be 4 minus 4, which is 0. B will carry the 4 down here, which is the 4. So that's what we are going to have there, which is going to be equal to, now, we said n choose 0 gives us what? A 1. So this will be a 1. So we have 1 times a to the power 4. B to the power 0 is also a 1. So here, we only remain with a to the power 4. Plus, now, let's try this one. 4 choose 1. So we have 4 choose 1. This is going to be 4 factorial over 1 factorial. Then we have 4 minus 1 factorial, which is going to be 4 factorial over 1 there is 1. 4 minus 1 is 3 factorial. This is going to be 4 times 3 factorial over 3 factorial. This 3 factorial and that 3 factorial cancels, so we remain with just a 4. You see that? Yes, we remain with a 4. So here, meaning here the coefficient is a 4. Then we have a to the power 3, b to the power 1, we can just write b. Plus, is that okay?
Yes, sir.
Yeah, let's try, get the ball here. Let's try the other one, which is 4 choose 2. So we have 4 choose 2, which is going to be 4 factorial over 2 factorial. Then we are going to have in brackets 4 minus 2 factorial, which is going to be 4 factorial over, outside here we have 2 factorial, 4 minus 2, we still get another 2 factorial. So this is going to be 4 times 3 times 2 factorial over 2 factorial times, then the 2 factorial will simply be 2 times 1. Okay? So this 2 factorial and that 2 factorial are going to cancel out. 2 here, 1, 2 into 4, that's 2. So down here, there's nothing that has remained. We only have 1. So on top, we have this 2 times this 3, which is going to give us a 6.
6.
So we have the coefficient here as 6. So we have 6, then a squared, b squared, plus. Now let's come to 4 choose 3. To this one now here. So for that one, we are saying,
4 factorial.
yeah, so 4 choose 3, we are going to have, we have 4 choose 3, which is going to be 4 factorial over 3 factorial,
3.
4
Open
minus
brackets 4.
3 factorial, right?
Yes.
Then from there, this is going to be 4 factorial over, we have 3 factorial. Maybe we can reduce this one, 4 times 3 factorial. Then 4 minus 3, we have 1 factorial, which is just 1. Okay? So we know this cancels with that. So we just remain with a 4. That 4 here. So this coefficient 4 choose 3 gives us a coefficient of 4. That's how we have the 4 there. Then we have a to the power 1, which is just a, then b to the power 3, plus. Now remember, n choose n, we said the coefficient is 1.
Is 1, yes.
And a to the power 0, it's 1. So finally here we only have b to the power 4. So
you
we
should
have,
send the video immediately when we're done.
come again?
You should send the video when we're done, just
Yeah, so the video will be ready tomorrow. After we are done, I should send you the one for yesterday. So you see that this and this are exactly the same. But for this one, we have used the formula. Yeah, we have used the binomial theorem to get this. Here we use the Pascal's triangle. So you can use any of the two, you get exactly the same results.
Yes.
Yeah, is that fine?
It's fine. You should
Yes.
send the video for yesterday.
Yes, so let's do the last part. Let's do the final part, then we can solve one question or two, or maybe I can just give you an exercise after we have solved. So since we have learned the binomial theorem, it's very critical. A lot of questions come under this part where we have reached. This is where you have a lot of questions. Yeah, so one of the questions that we can have is, I'll leave this expansion down here. I'll leave the expansion down here so that we can use it for reference. Now,
Alright.
there are questions that will come to say, find the expression in the expansion of this which is independent of x. Okay, find an expression. Now, since here we don't have x, let's use a, which is independent of a, since we don't have x there. But usually you have x and y the other side, so it's the same concept. Here, since we have a plus b, there is no x here, we only have a and b throughout. So now, a plus b to the power 4, and then you're asked to find the term which is independent of a. What this simply means, this statement means, you're supposed to find the term here in this expansion which doesn't have an a. Okay? So when we look at this, the only term that doesn't have an a is the last term here, which is b to the power 4.
Yes.
Yes. So b to the power 4 is the term that doesn't have the a. So this term is independent of a. And also one thing you need to understand is that the same last term that we have, the same b to the power 4, we need to find which term it is here. We need to, with that one we can simply count. So we have 1, 2, 3, 4, 5. So this is the fifth term. Yeah, so b to the power 4 is the fifth term, and this is the term that is independent of x. So now let's see how we can get to this without doing this entire expansion. We're going to use that small part of the binomial theorem formula, that small part which I mentioned to say we need to pay particular attention to it. That's the one we're going to use to get to this. So if you remember that part very well, we had n choose r minus 1, then we had a to the power n minus r minus 1, then b to the power r minus 1.
Yes.
Yeah, if you remember very well. So the r is the term. That's why this is called the rth term. This is used for finding the rth term, a specific term in the expansion.
We'll replace it with 5.
No. Since we assume we don't know, we want to confirm whether it will be the fifth term.
Okay, alright.
So we assume this one is not there. We want to also confirm whether the term that doesn't have an x is b to the power 4. And we also want to confirm the term. What term is it? Is it what term? So we want to use this formula and confirm what we have here.
Alright.
Yes. So this is going to be equal to, so the n is this number here, which is a 4. Then we have r minus 1. Come, Daddy. Come, Daddy. Don't let him come. Okay, so let's continue. So the n is 4, r minus 1. We assume we don't know the r, which is the term, so we leave it there. Then the a, we know it's the a there, a. Then we have the n here is the 4. So we have 4 minus, then we have r minus 1. Okay. Then the b is the same b. The same b. Sometimes the a here there will be x, the b there will be y. You need to replace them here. So we have r minus 1 there. So this is going to be 4 r minus 1. Then we have a. We need to expand here to take the negative inside there. So we have 4. Negative times r, we get minus r. Negative times negative 1, we get plus 1. Then b to the power r minus 1. Okay, so this one we can count. So let me just remove it there. So you can say if we bring it there, so we're going to have 4 r minus 1, and then we have a. Now 4 can add with 1 to give us 5. So 5 minus r. I hope you understand that 4 plus 1, because this is one term. So 4 and 1 are like terms. They can add to give us 5. Then we have minus r. Then we have b, the power r minus 1. So when we reach here, after we are done with all this expression, when we reach here, we are told that the term we are looking for doesn't have an a, or rather the a is to the power 0. So now we pick this one, this a which we have there, and equate it to a to the power 0. So we have a to the power 5 minus r. We say this is equal to a to the power 0. Because when you have a to the power 0, it means the a there does not exist. Because a to the power 0 is 1. I hope you understand that.
I'm getting this one.
Yes. So because the bases are the same, the numbers down here are the same, so we equate the powers. So we're going to have 5 minus r is equal to 0. So we take the r the other side, we are going to have 5 is equal to r. So meaning the r we are dealing with is the 5th term. So r is equal to 5, simply telling us that we are dealing with the 5th term. And when we counted here, we had 1, 2, 3, 4, 5. Exactly where there is no a, or where a is to the power 0, it's on the 5th term. So this is how this formula is used. So we have found the term, which is the 5th term. Now, let's get the expression. What do we have on that term? We need to apply wherever there's r in this formula at this stage. We put 5. Then we are going to get what we have there specifically. So let's replace r with 5. Wherever there's r, we put 5. So we're replacing from this stage. So we have 4 on top. Then r here we have 5 minus 1. Okay, and then we have a 5 minus the r is 5, so we put 5. Then b r minus 1, the r is 5 minus 1. Okay, so which is going to be 4. Choose 4. So a to the power 5 minus 5, that is 0. B to the power 5 minus 1, that is 4. Now we know that 4 n choose n is 1. So 4 choose 4 is 1. A to the power 0 is 1. So we only remain with b to the power 4.
Okay.
So that is the term which we have, which is independent of x, and it's on the 5th term.
Yes.
Does it make sense?
It does.
Great. 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 Great.
You should bring this one.
Who should bring Trace?
You.
No, I'm not part of the process.
We both know.
We just submit
bring
the
this
topics. We just submit the topics that we have covered, and then those guys do the needful. Just that when I was teaching, I was picking examples from past papers. So it looked as if I was the one that was taking. Tracy. So which term can we look for here? Which other term can we look for since we're able to get this one? Which term can we look for here? Pick which one?
Let's pick 4A.
There's this one and this one. There are 2 4s there. Which one?
This one, the second one.
This one? So we pick this one. So sometimes you can be asked to say, find the second term in the expansion of this. Find the second term. So when you're asked to find the second term, This simply means r is equal to 2. Okay, so we have our formula n choose r minus 1, then we have a to the power n minus r minus 1, then b to the power r minus 1. So here we already have the r, because we are told to say find the second term. If we are told that, so meaning the expansion is a plus b to the power 4. So we know the n is 4 there. 4, then the r is 2. So we're going to have 2 minus 1.
That's one.
Yeah. Then here we have a, then we have n is 2, n is 4 rather. 4 minus, our r is 2, 2 minus 1. Then we have b, our r is 2 minus 1, like that. So this gives us, we have 4, 2 minus 1 is 1. So 4 choose 1. Then we're going to have a, 2 minus 1 is 1, right? Then 4 minus 1 is 3, isn't it?
Yes.
Yes, it's 3 there. Then we have b, 2 minus 1 is 1. So we just have a 1 there. Now, we need to work out the 4 choose 1. So 4 choose 1 is simply 4 factorial over 1 factorial, then 4 minus 1 factorial, which is going to be 4 times 3 factorial over, this one is 1, 4 minus 1 is 3 factorial. So this 3 and that 3 cancels, we remain with our 4. So here we get a 4 there. So this is going to be 4a to the power 3b. This is the second term. So you don't need to expand the whole thing for you to find that particular term. And when you look at this, these two are exactly the same. So we have this is exactly the same as that. So we have found the second term in the expansion of that of a plus b to the power 4. Yes. Any question, Trace?
There's no questions. It's processing. Stuff for processing.
Yeah. So this is what we can talk about under binomial. The only part that is remaining, perhaps maybe we can tackle it tomorrow. The only part that is remaining, where instead of having a plus, let's say a plus b to the power n, now you have 1 plus x to the power n. So this is a special term. So we look at this one tomorrow, then we are done completely with binomial. Obviously, this will take us just about 10 minutes or 5 to 10 minutes, we'll be done with this. Or maybe 15 to 20 minutes will be done. Then if you like, if you wish, we can move on to a different topic, which should be guided by the next question in the paper we are solving.
Oh, okay.
Yes, so because we had binomial there, that's why we have paused and diverted into this whole lesson for binomial. And then from now, you expect me to send you some questions that you need to solve that are like this.
Yes.
So what you need to do is, when I give you the questions, you solve them like I did those that I gave you. Solve them, and then